Hi, so welcome to Upgrading Pharma channel. So today we are going to discuss about what is polymorphism and what are the examples for polymorphism, types of polymorphism, significance and its application in pharmaceutical industry. Okay, so let's enter into the video. So first, polymorphism. So what is polymorphism means? So we also know that the solid particles have exist in crystal as well as amorphous form. Okay, so amorphous is the powdery in nature and it is more soluble and less stable, and crystalline form, that is more stable, less soluble nature. Okay, so when the solid will be exist in a crystalline form, it have the ability of existing more than one crystalline form. Okay, so that is alpha, beta, gamma, so any other. Okay, so it have more than one crystalline form. So this ability of the particular crystal is called as polymorphism. Okay, that is the ability of the drug or the compound crystallize. Okay, so crystallize in more than one form. Okay, so when the solid particle will be crystallized in more than one form, that ability is called as polymorphism, and that is the definition for polymorphism. So many crystalline compounds can exist in more than one crystalline form with different internal structure. Okay, so crystals are the unit, that is a unit. Okay, so this is a unit arrangement. So when the solid will be exist in different states, that is different crystal form, so the molecules are arranged in the particular crystal will be vary from one form. Okay, so that is the different internal structures. So this state is called as polymorphism. Okay, so these are the definition for polymorphism, and the polymorphic forms usually exhibit different physiochemical properties. So these different physiochemical properties is due to the differences in the arrangement of atoms in the particular molecular compound. Okay, so when the molecules will be arranged at different levels, so it will lead to the difference in their solubility and melting point and density, crystal shape, optical and electrical properties. Okay, so these are the main consequences of the polymorphism, and this chemical stability and solubility changes due to the polymorphism can have an impact on drug availability. Okay, so when the chemical properties, that is solubility, will be changes, so it leads to differences in the particular bioavailability of the particular drug and its development program. So why it will impact on the development, that is when the solubility of particular drug will be decreased, so it is difficult to make soluble and increase the bioavailability. So there is a main concept, that is development program. Okay, when the chemical factors will be changes by the polymorphism, so it leads to drugs bioavailability and development programs. Let's see the example to understand the polymorphism, that is chlorophenicol. So chlorophenicol polymetate exists in three crystalline polymeric forms, that is A, B, C. Okay, so it also exists in amorphous form also. In that crystalline form, B form, that is structure B, will be have highest peak serum level. Okay, so it indicates it have the more bioavailability than the other A and C. So we can make the chlorophenicol polymetate in the structure B form, that is a crystalline B structure. Okay, so it have the higher absorption and higher stable and most preferable one. Okay, so these are the one of the example for polymorphism. So how we can extract this particular structure, that is due to the sublimation, due to crystallization, by using evaporation, we can unique polymorphic form will be obtained. Okay, so these are the some techniques to obtain the particular polymorphic forms, and these polymorphic transition can also occur during the granulating, drying, compressing operation, that is during the tablet manufacturing process. So these structure changes will be also happened. Okay, so these are the some definition as well as some points about the polymorphism. So next we go for the types of polymorphism. Okay, so there are two types of polymorphism, that is enantiotrophic polymorphism, monotrophic polymorphism. Okay, so enantiotrophic, which means, so when the temperature and pressure will be changes, the stability of the particular crystal form will be changes and it leads to the most stable form. Okay, so if the form will be exist in A, then we can introduce temperature and pressure, so this form will be unstable. Okay, so this form will convert it into the B form. Okay, that is a B form which is more stable at particular temperature and pressure. Okay, that is temperature and pressure of the surroundings will determine the stable form of the particular structure. So these are the inertiotrophic, that is the structure, that is the change of particular structure will be depends upon the temperature and pressure. Okay, so that is inertiotrophic polymorphism, that is change in temperature and pressure determine the form which is stable. Okay, so example for the inertiotrophic polymorphism is sulfur, carbon and nitrogen. Okay, so these are the some example for inertiotrophic polymorphism. And the second one, that is monotrophic polymorphism. Okay, so this is very stable and it does not changes according to the temperature and pressure. Okay, so this is a monotrophic polymorphism, that is the name mono. Okay, it will be existing only one form. Okay, so it does not respond to the temperature and the pressure exist on that particular crystal structure. Okay, so example is glyceryl stearate. So it is one of the example for monotrophic polymorphism. So next, that is significance of polymorphism, that is why we can study the polymorphism. That is we have to discuss that the crystal habit and internal structure of the drug can affect both physiochemical properties. So we also seen in that particular definition, so it's also affect both physiochemical properties, example solubility and stability. So these are the main factors affected by the polymorphism of the drug. Okay, solubility if affected and it leads to the instability of the particular compound. So these are the significance. And the bulk characters, that is flow property, compression behavior. So flow property, which means so one type of crystal have higher flow property than the other type of crystals. Okay, so it's also main, so that we will study the polymorphism, and in turn bioavailability and dosage form process functions. Okay, so these are the main significance of the polymorphism. And I forgot to told that so polymorphism is the one of the free formulation studies which determines the stability and solubility of the drug. Okay, so it comes under the physical stabilities. Okay, so physical properties of the particular drug. So next we can go for the applications of polymorphism. So where these polymorphism will be exist. So first one, that is suspension. Okay, so suspension we already know that is insoluble solid particles will be dispersed in the liquid medium, that is suspension. So suspension phase, that is transformation from unstable form to more stable polymorph, can cause changes in the crystal size and leads to caking. Okay, so if the solid is present in the A structure, then it will be converted into the B structure. Okay, so due to some reasons it will be converted into B, then this B structure will be separated from the liquid and form the cakes. Okay, so these are the main incompatibility in the formulation of suspension. Okay, so when the crystal this function will be changes, this leads to the incompatibility of the particular suspension. Okay, so these are the main applications of polymorphism, so that we can study and we can improve the particular stability of the state of crystal structures. Okay, in suppositories, changes in the polymorphic form can cause product with different and unacceptable melting characters. So we also know that in suppositories, that is theobromo oil. Okay, so theobromo oil exists in 3 crystal form, that is alpha, beta and gamma. Okay, so from that beta is melting at 35 degree Celsius. So when these beta theobromo oil injected or insert into our rectum, that will melt in that particular temperature, that is 35 degrees Celsius. Okay, but in theobromo oil in gamma state, it is melting point have 18 degrees Celsius. Okay, so it is below the room temperature. And when this theobromo is present in alpha form, it have 22 degrees Celsius. So it is almost below the room temperature. Okay, so in theobroma, the B form have the correct melting point for the manufacturing of suppositories. Okay, so these are the main 2 applications of free formulations, that is suspension and suppositories. Okay. So these are the main applications, and I hope so this video is useful to understand the concept of polymorphism. So kindly subscribe our channel and click the bell icon near to subscribe button, and also share this video to your friends also. So thank you for watching.